We continue to search down why this thing won't start, and what we're targeting now is the ignition system. So now what I'm doing here is I'm checking my power to the coil. So we're gonna start from there and then work our way out. So we're gonna confirm power to the coil, gonna test the coil, gonna test the coil wire. What I've did was I created my own test leads here. And really all we're doing is we want to see that we've got power. So we've got a positive and a negative that are going into our coil here. And then we have a primary and secondary. The initial power going in, we just want to see that we have that. So we have our two leads going to the plug that goes into the bottom of the coil here. And then I've got those two leads and I've got them to my test light here. So I've got a positive, and then as the negative comes down, I have the negative to there. So really all we want is that light to prove that we've got power when we try to turn it over. I'm going to turn it over and you should be able to see some light from the test light over there. It may have been hard to see through the dirty broken windshield there, but we did verify that we did have the light come on as we attempted to start the vehicle. So now the next thing that we want to do is we're going to remove that coil and test it, and then we're also going to remove our coil wire to the distributor, and we're going to test that. We've got a new and old coil wire that we're going to check the resistance on, and when we're doing that we're setting our meter to ohms. That's our little symbol there. We're going to go 20,000, and then we're just going to probe either side of the wire. Now before we get started, what we did was we measured the new and the old wire, and they both came out at 38 inches long. The reason you need to know the length is because apparently it's a roughly 5,000 ohms resistance per foot. So when we divide that, we get a factor of 3.1. So we would take that 3.1 and we would multiply that by 5,000, and this was the number that I got. Probing here, we're going to check our old wire. I've got it on the meter there. So that's our old wire. That's what we're getting, 12.83 or 12,000 plus. Now we're going to check the new wire. So we see it settle out there at 15,000 plus. And as compared to our reading that what we're supposed to get, so we should get 15.83, we're getting more like 15.5. If anyone was curious to the part number for the new wire set that I got for this was the part that I got for this job here. Moving on, we're going to check our coil. So here's the new coil part that we got. Anyone interested? So we're going to check the old coil compared to the new coil, get some numbers there. This is just removed by two fasteners. In my case, I've switched it over to 1/4-inch bolts. I do believe that the original fasteners are like a Phillips screwdriver head fastener on there. So next what we got here is the coils. We're going to check those. We're again going to check our resistance. So we're setting it to ohms. So we've got it on ohms, we've got it on 200. So this is going to be the primary, which is the two plugs on the end. You see the two pins in there. I've got my alligator clips, so they're just touching each outside of the pin there. Now if you remember, this is where we set our test light to the plug. So we verified that we've got power to the plug, so the power then is coming into the coil, the low end, or the primary side of the coil. So that's why we have our setting at 200. And when we took a look at our numbers that we're supposed to get, primary should be getting at this setting 0.8 to 1.5. And then when we switch over to our secondary, we're looking at, we're going to be 10.5 to 14,000. And so to test that one, that's when we're going to get up to the 20K. Check what our resistance is here on the primary, and we are looking at 1.5, which is at the top end of what we're supposed to get, and that is on our brand new coil. We've switched the leads over to the old coil now. We're going to do the same check on this one and see what the reading is. And you can see that this one's in spec as well. So both the new and the old are within that 1.5 spec. Now we're checking the secondary side of the coil. This is going to be where it gets amped up from its feed to its discharge point, and that is why we have to change our setting to our 20,000 K on the meter here. And in this case, you got to find your probe in there, and they hook one probe here, one probe on one of those. We'll take a look on the meter here as we check it. And we're 12,000 plus, 12.76. That's right in the middle of our 10,000 to 14,000. Now we got the lead set up on the old one, and we're going to see what the reading is on it. We're getting 11.39. Now that is still within spec according to our numbers. It's above the 10.5, but it is lower than what the brand new one is. This engine here doesn't have a Schrader valve available in the fuel line so that you could hook up a pressure gauge and check for fuel pressure on it. So what I've done is I've disconnected my fuel connection into this fuel rail here, and then there's that hose that connects it over to the other side. So I've disconnected that on there. I've got this bottle on here. Now when I disconnected that, there was no pressure. So that's telling me that we've got a fuel issue here. But what I've got is I've got this bottle in here, and I've got our fuel line coming in there, and I'm gonna touch the battery over there. I've got the ignition on, and I've got our relays. I have the relays bypassed over there, so as soon as I hit the positive onto the battery, it should engage the pump and start pumping into our bottle here to verify that the pump is working or not. I'm just gonna touch it to the positive here, get a connection. But we do have fuel. The fuel is coming, but why don't we have any pressure? The pressure relief valve could be malfunction, so then it's not maintaining pressure in the fuel line here. That might be one problem, but it is pumping and it is supplying the fuel. We can see that in there. I found some information that a bad MAP sensor, that's the mass air pressure sensor right there, or a bad idle control sensor, which is right there, may cause a no start condition. I changed those sensors. Those are two new sensors there. This one here would be the throttle position sensor. Didn't change yet, just changed those two. And again, we have a no start condition. In the process of changing those sensors, what I like to do is I like to change the screws over to a Robertson. So I've changed all the screws over to a Robertson, and I clean this throttle body up, put it all back on there. We still have a no start condition here. We remove the fuel line, prove that the pump is pumping into that jug. There was no pressure though. After that, I'm going to think that the fuel pump or the fuel pressure regulator or something in there is not working properly. We could have injectors that are working, but they aren't delivering enough fuel. That's what I'm going to target next to see if we can get this thing started. Right here's our new fuel pump, and if anybody wants a part number, that's what we got going on the side there for the part that I'm using to replace this fuel pump in this vehicle. Here's an example of those screws that I just mentioned. These are for the MAP sensor. These ones here will likely be for the throttle position sensor. These two here will probably be for the idle control sensor. Then this one here is for basically setting the throttle. You just crack it open just a touch there, or at least the factory, you just crack it open just a little bit to get it set. So these are all the factory fasters here, and all of them have that Torx end on there. What I like to do is I like to switch it out from that Torx end to a Robertson end. then it's a lot easier just to change these. And basically, if you take a look, this is a number 10 by 32 threads per inch machine screw, and that is the same as what we've got going on here. So basically that's pretty much the same thread pitch right there, and that's what I'm using to replace those. And all you need is just your length of screw. So this one here is the same length as that, and then for those ones there you get a shorter one, or you can take one of these and cut it down. And then for that one there, you probably have to get one that's have to find that special size to make that work. Now all of them are easily removed and replaced with a Robertson screwdriver rather than a Torx bit. Another thing I feel I should mention here is that all the way through I have been checking for codes, and there hasn't been any codes to help us identify what the problem is here. We've got the code reader connected to the OBD reader here, and when we go in and we hit on there, we have no codes. And we haven't had any codes all the way throughout, which hasn't really helped us out with this problem to try and identify it. That is one of the reasons I don't think that we have any fuel injector problems, because there's no codes coming up on that. That was another reason why I felt that the map sensor and the idle control sensor weren't a problem, because there were no codes that came up on that as well, or the O2 sensor. So those sensors, I felt, I think it's one of those conditions where they read and supply information to the ECM, but I don't believe that there's a malfunction in any of those that are going to prevent the vehicle from starting. We're going to get ready to drop the fuel tank so that we can replace our fuel pump assembly there. We got to disconnect our hoses here, and then I have a deep socket that's going to be a 9/16 to get at our two straps right there. So there's one, and then the other one's back there if you can see it. Then we'll unplug our connector here, and as we let it down, we've got some lines to disconnect as we're letting it down. So those are our connections here. We've got our electrical, we've got our straps that are holding the tank in, and then we have our filler hose connections right here that we're gonna disconnect. Got the gas tank dropped out. Actually wasn't that bad of a job. Little bit of a trick to get at our hose clamps on this side here, but other than that, not bad. Lubricated the studs, or the rods I guess you would call it, for the tank straps. Just had to work those, lubricate them, 9/16 socket, deep socket to get that off. Actually came off not bad after lubricating all the threads and everything like that. And then we just got our plug here, and then right here, if you trace that out, that's just the vent line. This is just a rubber piece of hose, and you just pull that off of the other part where it connects to. And then this one here, that's going to be our fuel line. And if you can see right here where this squeezes together, so basically what I did was I just used a pair of vice grips, and I held that on there tight, consistently tight, and then I just kind of slowly pulled and pried that off of there till it came off. And now I have everything taped off. I've got this taped off, that taped off. I have these Ziploc bags taped on our filler and our vent, and then now that is so that we can blow this all clean and we won't get nothing inside the tank, and get ready to change the fuel pump. Got it all cleaned up, and we started to remove the old pump here, and what I did do is I disconnected the hose there, which is the same style of clamp. If you get in tight here, you're gonna grab some pliers or something to press that down, and then pull the hose off of there. Also took the hose off of there, just so there's as much room as possible, and I took that ring off of there. So there's the ring, and then that's just basically, I'm just using a flat screwdriver and hammer, but you got to be gently bently so you don't break your tabs off of here, shear them off, because it is plastic. So what I did was I marked this ring so So that's my starting point, roughly in here in this valley. Wasn't exact, but it's in this area. It goes counterclockwise, and it's probably only going to be 1.5 turns. It's not very much. So then take the ring off. Now I'm going to pull the pump out. I'm going to put it in a bucket here, and then we'll put the new pump in and reassemble everything. Here's the new pump installed, and the thing to notice is our mark. So the last one was in here somewhere. I don't remember exactly where, but that's as tight as I could get it. You want to go too tight because you start to shear off your little stubs here that you're hammering against with a screwdriver, blunt chisel, or whatever you have. So we hooked up our hoses here. We got the pump hooked on here, ready to go in. That's the old one there. The filter had detached itself from the pump. And then that is the remnants of an old filter. So it looks like this has been changed before a couple of times. There was a little bit of sediment in the tank. I drained the tank. Can't get it all out because there's no good drain on the tank. So there was a little bit of sediment left in, but we got all the big stuff out. Some broken plastic was in there, nothing too serious. I had mentioned once before that what I would like to do is I would like to cut a hole in the floor, so that if you had to, or it would be an option to replace this fuel pump from the top rather than dropping the tank and everything. I haven't decided whether or not I'm going to do that, but if I do it, this is the hole that needs to be cut. If you look right there, that's where one of the straps go, and that's where the other strap goes. So just on the outside of my taped lines here, and then there's some framework back in there. You can actually see the recess. That's where the frame is. So basically what I've done is I've taped it off and measured. So I've got 12 7/8. That'll be from the inside here and here. And then over here I got 19.5. And again, that's from the inside edge here and here. The tank gets installed like this, and that's where one of those straps are going to be. So it's very close to where the edge of the pump is. Back in here, I don't know if the edge of the pump is going to be in behind where this edge is or not. If we look underneath here, here's where that frame is. It goes all the way. That's also where the strap connects there, where that square is. So it's basically parallel with this frame portion here. If we were to cut that hole out, what I would do is I'd want to come in just a little off the edge of the frame here. And I don't know if that would be enough in order to get that pump out. At any rate, I haven't decided to do that yet. I've just been measuring it up, and this is kind of an FYI for anybody else that's considering such a thing. At least you'll have an idea on the location of where it is. It's likely going to be about in here, but what I would do is I would move that whole center section as big as I could to get lots of room to do whatever you needed to do there. Everything's all hooked up in here. We've got our connection here for the fuel line. We've got our connection right here for our vent. That's one of the tank straps there. We have our electrical, and this little piece here that's going to plug into this hole right there. But I haven't put it in there yet until we're finally done. Then I'll put that in last because I don't have to pull it out again if I have to. Right there is our tank strap stud. So what I like to do is I like to use a coupler nut, and this is my adjustment. And then underneath the coupler nut I got a nylon locker, and then below that I've just used some black tape to protect the exposed threads so that they don't get all corroded, and then it becomes real difficult to take off like it was to begin with. And then in here is our filler tube and our vent. We had found earlier on that this was cut straight through this hose. It is sheared straight through right there. And then I found on this side there was a tear in here. If you can see, it's kind of like a V-shaped tear. So I think what happened was fuel pump has been changed once or twice before, and maybe when they tried to drop down the tank, they damaged the hoses here and there, or somebody just simply cut that, got frustrated, cut that, and got it out of there. Problem is that these hoses aren't readily available, so I had to repair what I have for the time being until I can try and find something to replace it with. So I'll show you on the bench what I did to repair that. On the bench here I have a chunk of hose as a demonstration as to kind of what I did. So what I did for the one that was cut, where it was just cut straight like that, I just cleaned with the wire wheel here, I just cleaned the end of the rubber up with that wire wheel on both sides, and then I'm going to use this stuff here. It's like a super glue, and then I put that on there, and then I glued it on, and then after it was glued on, then I ran the super glue around the outside to kind of give it another layer there. Now on the one that was ripped and tore, kind of like this, say cut like that, I did the same thing. I would clean up the rubber all around, so I'd clean it on the outside here, and I would clean it as much as I could where it was split like that, and then so the adhesive would work really well, and then I put in that adhesive, and then I hold it, and then once it's good, I would run it down the crack after it's done. So that's why I'm cleaning the outside on both ends, and then also right there where it's gonna get glued together. So far it's been holding up really well, and that's a very inexpensive fix right there. Just some of this super glue. I imagine any super glue would work. This is just what I have. So if you have like super glue or something like that, clean it up really good. I used a wire wheel. You can use your own methods of cleaning the rubber really well and gluing that up, and maybe get some more life out of it. We filled up our gas tank. Obviously we want to get a lot of gas in there to charge up the system and to make sure that there's lots of prime and keeps the pump cold while it's doing its job and everything. So we've got gas in there, and now after we've changed that fuel pump, we can see if it's going to want to start for us here. And we still don't have any luck getting this thing to start. After putting in that fuel pump, we'll see if we got any codes that are coming up on the code reader here, and might give us a clue as to what's wrong. So far that hasn't been the case. It hasn't given us a direction to go to try and get something. And you can see again that we don't have any codes there. All the way through here, whatever the problem is, it's not throwing a code at us. So we got to move on to the next thing.